Back in late 2019, astronomers using the Atlas Survey telescope in Hawaii spotted something unusual. It was a faint, fuzzy object moving through our solar system. At first, it looked like a typical comet, but as they tracked its path, they realized something extraordinary. This object wasn't from around here. Its trajectory was a hyperbola, meaning it was moving so fast that our sun's gravity could uncapture it into a stable orbit. It was just passing through a tourist from another star system. This marked it as only the third interstellar object ever detected. Officially named 3IATLAS. The I stands for interstellar, a true cosmic immigrant. Now, you might remember our first two interstellar visitors. The first was Oumuamua in 2017, a bizarre, cigar-shaped object that sped up as it left our system, sparking wild theories about alien technology. Then came to Borisov in 2019, which looked and acted much more like a conventional comet, complete with a dusty, gassy tail. It was our first confirmed interstellar comet. So, where does 3IATLAS fit into this growing family of cosmic drifters? Well, this is where things get really interesting. 31ATLAS is different, very different. When astronomers first observed 3IATLAS, it appeared cometary, meaning it had a coma fuzzy cloud of gas and dust surrounding it. This happens when a celestial body made of ice gets close to the sun, and the heat causes the ice to turn directly into gas, a process called sublimation. So initial thoughts were, okay, another interstellar comet like Borisov, but as it journeyed closer to the sun, something unexpected happened. Or rather, something *DIDN, single quotes T*, happen. Unlike a typical comet from our own solar system, which would become increasingly active, spewing out vast quantities of dust and gas to form a spectacular tail, 3I Atlas remained stubbornly subdued. It brightened a little, but it never developed that classic, long-flowing tail we associate with comets. This was a huge puzzle. If it had enough ice to create a coma when it was far out, why didn't it put on a bigger show as it got hotter and hotter? The closer it got to the sun, the more puzzling its behavior became. It just ... fizzled. This led to a fascinating new theory proposed by a team of researchers. What if 3I Atlas isn't made of the same stuff as our comets? Our comets are primarily made of water ice mixed with dust and rockwater. We affectionately call dirty snowballs. When they heat up, the water ice sublimates vigorously, but the behavior of 3I Atlas suggested it was made of something far more volatile, something that turns to gas at much, much colder temperatures. The leading candidates: frozen nitrogen, carbon monoxide, and carbon dioxide. In other words, 3I Atlas might not be a dirty snowball, but an interstellar snowball made of frozen gases that we typically find in the atmospheres of distant worlds like Pluto or Triton. Think about it. These supervolatile ices would have started sublimating long before 3I Atlas even got close to the inner solar system, way out past Saturn's orbit. By the time it reached the point where we could get a good look at it, it had already lost most of its gas-producing fuel. It was like a firework that had already spent most of its powder before the main event. What we were seeing was the last little puff of activity from a nearly exhausted object. This explains why it had a faint coma early on, but never developed a significant tail. It had essentially run out of gas, literally. This interstellar snowball hypothesis is incredibly exciting because it gives us a potential sample from a completely different type of celestial body than we used to. Comets in our solar system formed in a protoplanetary disk, rich in water. But perhaps 3I Atlas formed in a very different environment. Maybe it's a fragment chipped off a Pluto-like dwarf planet in another star system. Imagine a giant impact on a distant, icy world, sending a chunk of its frozen nitrogen surface flying out into interstellar space, destined to wander for millions of years before briefly passing through our neighborhood. If this is true, studying 3I Atlas is like getting a geological sample from an exopluto without ever leaving home. So, what happened to our interstellar snowball? As it whipped around the sun in May 2020, the intense heat was just too much for its fragile, depleted structure. Astronomers watched as the object broke apart. It disintegrated into smaller, undetectable fragments, a cosmic snowball melting on the solar sidewalk. While it's a bit sad that we can't study it anymore, its dramatic demise actually supports the theory that an object made of highly volatile ices would likely be structurally weaker than a rocky water ice comet, making it more susceptible to breaking apart under the sun's immense thermal and gravitational stress. The story of 3I Atlas is a perfect example of how science works. We see something that doesn't fit our expectations. We scratch our heads, and then we come up with new ideas to explain the data. First, it was just a dot. Then it was a comet. Then it was a weird comet, and now it might be our first glimpse of a nitrogen iceberg from another star. Each interstellar object we find adds a new piece to the puzzle of how planetary systems form and evolve across the galaxy. Oumuamua was weird and rocky, Borisov was a familiar-looking comet, and Atlas was something in between, a fragile snowball from a cold, distant world. What's next? Well, with new and improved telescopes, like the upcoming Vera C. Rubin Observatory, we expect to find many more of these interstellar visitors, perhaps dozens per year. Each one will carry clues from its home star system, telling us about the diversity of worlds out there in the cosmos. Some might be rocky, some might be cometary, and some might be bizarre interstellar snowballs like 3I Atlas. We are standing at the dawn of a new era of interstellar archaeology, sifting through the galactic debris that washes up on our cosmic shore. The universe is sending us messages in a bottle, and we're just now learning how to read them. Thank you so much for joining me on this journey to the outer reaches of our solar system and beyond. It's mind-boggling to think about the secrets these interstellar travelers hold. What do you think 3I Atlas was made of? Let me know your theories down in the comments. If you enjoyed this cosmic adventure, please hit that like button, and do not forget to subscribe and ring the bell so you won't miss our next deep dive into the mysteries of the universe. Thanks for watching, and keep looking up.